Okay, so very quickly we're going to cover graphics. First thing, custom graphics in Java is difficult, especially for novices. There's a lot of rules that are not fully explained. They're a little difficult to understand. So often you can have code where the syntax is perfectly valid, but it doesn't do what your graphics don't do exactly what you would expect they would do. So, and other times you can have problems that work in that happen in one context, but they don't appear in another. So, short version, where you can, find and reuse similar code that you know works. So if you can find something like a window that shows graphics in a certain pattern or that responds correctly to a button click, things like that, yeah, find an application where it does that and works fine and just borrow it. If you can't find something that works the same, generally you want to program in small chunks, like doing single components. And last, if you're just kind of beating your head against a wall and whatever you're doing doesn't seem to work, what you really want is to maybe try a different approach. So try some totally different technique, because what it probably means, if you're getting stuck but your code isn't throwing any errors in the IDE, it probably means there's one of these oddball prioritization rules that you've bumped up against. So just try a different way to do it rather than try to puzzle out exactly what happened. You can figure out what went wrong sometime after you finish the coding. Okay. So, graphics class is basically your paintbrush for drawing custom graphics on a J component. Graphics is actually an abstract class, so you can't create objects of it. So I have a little image here. The superclass of all these paintbrushes, these graphic subclasses, is abstract, so you can't create objects of the abstract class. But abstract classes can have subclasses. So what happens, whenever the Java virtual machine is installed on a new computer, it creates a custom graphics subclass that's specific to your hardware and operating system configuration. So basically, things like where your graphics card is stored in memory, where you draw things to make stuff happen. So, since any object of a subclass of graphics is also an object of graphics, that particular subclass object can do the custom drawing. Kind of a neat thing. Okay. So, drawing shapes. Graphics class has a whole bunch of different methods for drawing line and filled shapes. Anything that's a line shape generally has the format draw some shape. For example, draw a line, draw a rectangle, draw a polygon. All those will just draw single line shapes. If you want it to be a filled shape, you can do fill shape. And again, it would be like fill rectangle or fill polygon. And in these cases, for example, draw a line is from a line from one XY coordinate pair to a second XY coordinate pair. Draw a rectangle is from the upper left corner is the top X and Y, that's a coordinate pair, and then you tell Java how wide it is and how tall it is. That's the length, and it fills it in. So, coordinate entries specific to the components are always 0, 0 is the pair in the upper left corner. Okay. So, when components are painted, component class has a paint method that specifies how to display the graphics. So, 3 things that calling the paint method does. First of all, paints the component itself. So anything that's the actual drawing surface of the object, that gets done first. Second, Java will paint the border around it. So some components have a little line around the outside, it can paint them. Last, any children, any objects stacked on top of the component, Java will take turns painting them, right? Basically, if there's a J button on top of a J panel, for example, first Java is going to paint the entire J panel, then second, it'll paint the J button. And the reason for that is it's generally more efficient to just paint a whole surface in a particular color or particular style than try to figure out exactly where the boundaries of the components on top of it are. So, in general, you don't need to include or invoke paint unless you're overriding the superclass method. So unless you're doing something different, you don't need to worry about paint. All the GUI examples we've done until now, we just, added components, made the window visible, and boom, there it all was. But if you want to do something a little different, for example, if you want to do a different style of painting on a component, instead of having that washed out gray look, for example, or just one solid background color, if you want to do something different, then you have to override that paint component method. So, I have an example here. Okay, here we have a Fun with Graphics class that extends JFrame, so that's our frame class, our top level container. We also have a class FWG panel. Okay, FWG panel extends JPanel. So essentially what we're going to do is add this panel to our frame, and then we're going to make it visible. Well, what's different about this panel is that we have, I don't need that anymore. What we have done is overridden the paint component method. So paint component accepts as a parameter a graphics G object. Remember, G is, since we can't actually create an object of the graphics class, G is going to belong to some machine-specific subclass of graphics. We don't have to worry about that. Java solves all that behind the scenes for us once we've installed the Java virtual machine. So first thing we do is we call the superclasses paint component. So we saw JPanel's paint component method. So the component gets painted in the same way as an ordinary JPanel would. Then we're going to do a couple of custom things. So with G, remember, which is like a paintbrush, we're going to set its color. We're going to say, whatever you're going to draw now, draw it in blue. And what we're going to have it do is draw in a filled-in rectangle. So starting from the coordinate pair 100, 100, we're going to make it 200 pixels wide and 200 pixels tall. Okay, so if I run this, boom, there it is. I get this little window. Okay, I get this little rectangle. And if I wanted to have it be a line instead of a rectangle, instead of a filled polygon, and there you go, we have a little line there. Very easy. Okay, so again, this should actually be protected void. If you don't do protected there, you throw an error for it. There's a visibility problem. So this should be protected void paint component. Okay. So a couple more methods to talk about. Paint, repaint, and validate. So in general, if you add components to an already visible graphical object, the graphics won't update. So there's a lot of times you make changes to something. If you want to make the changes appear, you have to call the repaint method. Okay. So anytime you change something, unless Java's automatically scheduled a repaint on the object, yeah, you got to call repaint for it. The other one is validate. So remember, within our GUIs, there can't be any duplicates of objects. The other thing, if something in the component hierarchy changes, for example, you want to swap out one panel for another, you need to what's called validate the new tree. So top-level container adds components within a hierarchy. When Java is displaying it, remember, it has to draw the components first, then all of their children. Well, if you change what their children are, it's not going to display correctly. You have to tell Java, hey, I changed something with the component hierarchy, so now it's time to validate that. So top-level containers have a validate method. You can call that for your JFrame subclass, which basically updates all the references for all the components in the hierarchy tree and restores the overall layout. So for a visible frame, if you're making changes to the hierarchy, you should follow that by calling validate and possibly repaint to make sure that everything subsequently is displayed correctly. Okay. So, for example, easy way to rebuild GUIs if you want to, with custom JPanel subclasses. So, suppose you have an application, like say you're playing Angry Birds, and you want one screen to show when the game is actually being played, and another screen to show when you're picking levels, and another screen to, I don't know, maybe show high scores, whatever. Congratulations, you finished this level. Do you want to go on to the next one? Things like that. So you can have different subclasses of JPanel, one separate one for each configuration. And then, if you want to swap them out, all you do, first of all, so suppose we have two panels. One is called GP1, one is called GP2, and they're both, at whatever time they exist, they're used in a JPanel reference JP. So, first thing I want to do, if I want to swap out one, so initially I have GP1 in place. So first I remove the initial JP from the frame. Then I set JP to point to GP2, set it to point to the new panel, and I add it. I add the new panel. Okay. Then I validate it. I create the new tree, where I say, okay, all this component is now in place there, and then I repaint it to make sure that the frame is updated to show the new components in place. Okay. Last thing, colors, So we've talked about colors before, but here I'm just following up. There's two aspects to colors. First is the foreground. So what we talk about when doing custom graphics, that's a foreground color. We just draw some stuff on the surface and it appears. The background color is, of course, used in the background of a component, typically a solid fill on the entire component. What we've done in my example, we've set the graphics to be the color of the brush. There's other ways you can do it, but the easy one to do it is called g.setColor with the color you want to do. So if I wanted to in this component, I could also say this dot set background color green. Okay, I can still do that. In which case, my panel is green. I have this little blue line on it. Ta-da! There it goes. Foreground color always takes priority over the background color. Okay, and that's it for graphics. There's at least one demo program up on Blackboard if you want to check out a little more. Also, this won't be covered on the exam, but if you want to look at transparency and fonts, how to do those, different kinds of text on the on graphical components, it's in there in the slides too. All right.